Okay, so last time we talked about how to add and subtract radicals, and we talked about how to simplify those. We're going to go a little bit deeper today and talk about how to multiply and divide radicals. And with that, there's going to be a big rule that we're going to talk about later. So we're going to talk about how to rationalize the denominator. Okay, so when you're multiplying radicals, it's really, really easy. This rule up here makes it look difficult, but it's not. The gist of this is you multiply the outside times the outside, the inside times the inside. So if you have anything on the outside, so here A and B, you're going to multiply A times B. You're going to keep that on the outside. And then you're going to multiply C times D, and that's still going to be on the inside. Now you then have to check to see if there's any simplifying you can do. But if there's no simplifying that you can do, then you leave it like that. Okay, so let's look at this first example. So we're going to go outside times outside. So we're going to go 4 times 2, which is 8. And then we're going to multiply the inside, which is going to be the square root of 15. 3 times 5. Okay, and I just want to look at that 15 and make sure there's no factors within 15 that are perfect squares. Well, there's 1 and 15, 3 and 5, and none of those are perfect squares. So that is our answer. Number 2, we're going to have 2 times, that's just 1, so we're going to have 2. And then I have 18 times 3, and 18 times 3 is 54. Now, another way to do this, you can actually simplify that 18 from the very beginning if you want, just how we learned to simplify last time. Or you can make it a 54. It's just sometimes that number gets really big and it's hard to find the perfect squares if there are any, so it might be easier to simplify the 18 from the very beginning. Okay, but here I need to look at this 54, and there are perfect squares in 54. Remember, you want the biggest perfect square. So I have 9 times 6. And remember, here's how you know you have the biggest one. If I look at this 6, because 9 is my perfect square, if I look at 6 and there's still factors of 6 that are perfect squares, then I didn't get the biggest one. You want the biggest one from the very beginning. Okay? So if I take the square root of 9, that's 3. I'm going to bring that 3 out. But remember, we already have that 2 out there. So I'm going to multiply those. So now I have 6, and I'm still left with square root of 6. And remember how I taught y'all to check these last time. You can type 6 square root of 6 in, get that answer, and then also type in 2 square root of 18 times square root of 3, and they need to match up. Okay, number 3. So we don't have anything on the outside, so we don't have to worry about that. Well, it's just 1 times 1, so it's going to stay as 1. But then I have a times a to the 3rd. Remember, when you multiply, you add exponents, so that's going to be a to the 4th. Okay, it's just we need to simplify that, and the square root of a to the 4th is a squared. And that's it there. All right, here's some practice problems. I'll just go ahead and do these with y'all. So I have 2 times 3 is 6. So that's outside times outside. Now I do inside times inside. 6 times 7 is going to be 42. Okay, now we need to think about that 42 and see if there's any perfect squares in that. 4 doesn't go into 42. 16 doesn't go into 42. Remember that trick to check? You can go to your y equals. You can type in 42 divided by x, and this is going to get you your factors. So go to second graph, and you can see everything that multiplies together to get to 42. 1 and 42, 221, 314, 4 10.5. We don't want the 10.5 because it's a decimal, so it's not going to work. And then we get back down to 6 and 7, and then 7 and 6, so we don't have to keep scrolling. Okay, so here, that's going to be simplified because there's no perfect squares. All right, now number 2 is a little tricky because there's a few different ways to do this. It's not hard, it's just there's a lot of different ways to do this. You can go with the outside times outside, inside times inside rule. And if you do, you're going to get the square root of 81. But what is the square root of 81? The square root of 81 is 9. So our answer here is really 9. But look from the beginning, the square root of 9, that's 3, times the square root of 9, that's 3. So you have 3 times 3 is 9. So there's just a few different ways that you can do this, and you still get an answer of 9. Okay, number 3. Okay, same idea here. I see square root of 4. I actually know what the square root of 4 is. But we're going to go ahead and go along with our rule here. So outside times outside is 10. Inside times inside, 4 times 6 is 24. Now I just need to simplify that 24. All right, that's going to break down into 4 times 6. And I want to look at that 6, make sure there's no perfect squares in 6, and there's not. Okay, but I do know the square root of 4. The square root of 4 is 2. I'm going to bring that 2 out, but I already have a 10 outside, so I'm going to multiply those. So I now have 20, and then I'm left with square root of 6. Okay. All right, now we're still multiplying, except we're not multiplying just one thing times another. Now we're doing a binomial times a binomial, so 2 terms times 2 terms. And we should know to work this out that we are going to FOIL. Okay. Now, I could have talked about this on the last slide, but I'm going to talk about it now. When I do the first here, so when I do square root of 6 times square root of 6, anytime you do a square root times itself, it is going to be itself. So the square root of 6 times the square root of 6 is going to be the number underneath. So square root of 6 times square root of 6 is going to be 6. And here's why. If I use my rule of outside times outside, inside times inside, that's really the square root of 36. Well, what is the square root of 36? It's 6. So square root of 6 times square root of 6 is 6. But that's something, remember, you can check that in your calculator. Okay, so that's the first. Now I'm going to do the outside. So I have the square root of 6 times a negative square root of 2. So that's going to be minus. And I do outside times outside, inside times inside. So it's going to be square root of 12. Okay, now we're going to do the inside. That's a positive square root of 2 times square root of 6. So that's plus the square root of 12. Then I'm going to do the last, square root of 2 times a negative square root of 2. Again, this is a square root times itself. So square root of 2 times square root of 2 is square root of 4, but I already know that that's just going to be 2. Okay, so now from here, you can't just leave it like this. You have to try to simplify it. Now, I have 6 and I have a minus 2, so that's 4. And this one's actually really easy because when I see this negative square root of 12 and this square root of 12, I know that those are just going to cancel out. So my final answer here is just 4. But again, you can check this. Type that whole thing in your calculator from the very beginning, and it's going to tell you that it's 4. Okay, this just happened to come out as a nice answer. It's not always going to come out that way. Okay, so now we're going to be working with variables. So I'm going to do the first. Square root of a times square root of a. Okay, again, any square root times itself is going to be whatever is underneath that radicand. So square root of a times square root of a, that's just a. Okay, now we're going to do the outside. So square root of a times the negative square root of b. So that's going to be minus the square root of ab. Outside times outside, inside times inside. Okay, now we're going to do the inside here. That's going to be a positive, and then square root of b times square root of a. I'm going to write that in alphabetical order, so that's going to be the square root of ab. And then I'm going to do the last, square root of b times a negative square root of b. Remember, any square root times itself is just going to be what's underneath. So I'm going to have a minus square root of b times square root of b, just gets me b. Okay, so I'm going to see if there's any simplifying I can do. I have a negative square root of ab and a positive square root of ab, so those are going to cancel. To be able to do that, they have to be exactly the same. You can't have one that's ab and one that's abc. So that just leaves me with a minus b. And I can't simplify that anymore. Okay, So we're going to work some of these together. Number 1, now notice this is something that I just need to distribute. Okay, so I'm going to have the square root of 5 times 8 square root of 10. So I do outside times outside, inside times inside. So that's 8 square root of 50 plus square root of 5 times 1. That's just going to be the square root of 5. I just need to see if there's any simplifying that I can do here, and there is. The square root of 50, I can break that down into 25 times 2. Okay, the square root of 25 is 5. So I'm going to bring that 5 out, but I already have an 8 out there. So I multiply those. That leaves me with 40 square root of, I'm left with this 2, plus square root of 5. Okay, if those were both square root of 2's, then we could add those. But because they're different, it's like trying to add an x and a y. You can't do it. So you have to leave that the way it is. Okay, number 2, 2 root 3 plus 5 and all of that squared. Okay, remember what squared means? That's something times itself. So I need to actually write this out times itself. You cannot multiply it by 2. You cannot distribute that little 2. You have to write it out and you have to FOIL it. All right, so here we go. So we've got the first. So 2 root 3 times 2 root 3. So that's going to be 4 root 9. But remember, any square root times itself is just the number underneath. Okay, so 2 times 2 is 4. But square root of 3 times square root of 3 is just 3. Which leaves me with 2 times 3, which is really 6. But if you want to write it as 4 square root of 9, that's fine. You're just going to have to simplify it more later. All right, now I have 2 root 3 times 5. So I do outside times outside, inside times inside. So that's 10 root 3. Now I'm going to do the inside. 5 times 2 square root of 3. So that's going to be plus 10 root 3 again. And then I do the last. 5 times 5 is 25. All right, so let's see if there's any simplifying I can do. I have 6 plus 25, so that's 31. And then I have 10 root 3 plus 10 root 3. Okay, now we're just adding like terms. And as long as those are both root 3's, we can add them. So now I have 20 root 3 when I add those. Oh, and this 6 up here, this 6 was supposed to be a 12. I don't know what I was thinking. That's a 12, which means this is 37, actually. Okay, let me go back and talk about that. So 2 root 3 times 2 root 3, that was 4. And then root 3, root times root 3 was 3. So 4 times 3 is 12. Don't know what I was thinking there. Okay, but hopefully you would be able to recognize that if you were to check these. All right, number 3. So I've got the first, 6 times 6, that's 36. Now I have the outside, 6 times a negative root 3. Okay, that's just going to be minus 6 root 3. Now I'll do the inside, root 3 times 6, so that's going to be 6 root 3. And then I do the last. So root 3 times a negative root 3. Remember, a square root times itself is just that number underneath. So square root of 3 times square root of 3 is just 3. You can think about it as the square root of 9, but it saves time if you know that. So I have 36 minus 3 is 33. And I have a negative 6 square root of 3 plus 6 square root of 3. Those are going to cancel out. So my answer here is just 33. Okay, now we're going to talk about dividing radicals. And we are going to run into a little bit of a roadblock here. I'm going to go ahead and go to a slide down here that says there's a rule about simplifying radicals. You cannot have radicals in the denominator. If there are radicals in the denominator, we are going to have to, it's called rationalize it. Okay, so we'll talk about that here in a little while, but I wanted to go ahead and throw that in now. All right, so here we go. When you're dividing radicals, the rule is if you start out with, let's look at this second one. You start out with the square root of a over b, and all that a over b is underneath the radicand. That is going to break into the square root of a over the square root of b. If you can divide those numbers, then you can just divide them. So in this first example, if I have the square root of 6 over the square root of 3, I can just say that that's the square root of 2, because 6 divided by 3 is 2, which makes it really nice. It's just hard sometimes to recognize that. When we talk about rationalizing the denominator here in a little bit, some of you are going to start doing that on this type of problem, because you're going to forget that you can just do 6 divided by 3 here. But they both have to be under the radicand. You can't take something on the outside and divide it by something on the inside. Okay, and then just always check to make sure that that number underneath the radicand is simplified. But here it is, square root of 2. All right, the second one, we have the square root of 720 over the square root of 12. So again, if 12 goes into 720, you can go ahead and just divide those, and it does. We get the square root of 60. Okay, now I still have to make sure that that is simplified, so we need to think about factors of 60. Okay, and I know that 4 times 15 is 60. Okay, well the square root of 4, that's 2. So I'm going to bring that 2 out, and that leaves me with 2 root 15. There we go. Okay, number, for this third one, okay, we're going to break this apart, but we're going to stop after that because we haven't talked about rationalizing the denominator yet. We're going to talk about that here in a little bit. So the only thing I just want to talk to you about on this is because that 5 over 9 is all under the radical, we need to break it apart into the square root of 5 over the square root of 9. But I can't work this one like I've worked the last two because 9 doesn't go into 5. I can't do 5 divided by 9. So this is how we're going to leave it for now, but this is not going to be an acceptable answer because you cannot have a radical in the denominator. But we're going to talk about how to get rid of that here in just a little bit. All right, so here we go. Let's simplify. So this is the first one where we've actually had numbers in front, okay? But we're just going to divide those. Divide outside times outside, inside times inside. So I've got 6 divided by 8. Okay, so that's just going to be 3 over 4. And then square root of 10 over square root of 2. 2 does go into 10, so I can just go ahead and divide those. That leaves me with the square root of 5. And that's it. Okay, number 2, I need to break this apart. Okay, since it's all underneath that radicand. So I've got square root of 5 over the square root of 49. And let's look at this and see if there's anything we can simplify. Okay, well what is the square root of 49? Square root of 49 is 7. So that's the square root of 5. Which is, I guess, what I could have done on this last slide. Because I had square root of 9 on the bottom. So I could have just said that that was 3. So that's why that one's there. That makes sense. Okay, number 3. Okay, so I need to break this apart first into the square root of 16 over the square root of 81 and see if there's any simplifying I can do. So square root of 16, that's 4. Square root of 81, that's 9. 4 over 9, that's simplified, so that's our answer. Number 4, we're going to break this apart into the square root of x squared over the square root of 144. We're going to simplify what we can here. So the square root of x squared, that's x. Square root of 144, that's 12. So x over 12 is our answer. Okay, so think back to when you started learning how to divide. And because this is going to help us out for rationalizing the denominator. So think about what equals 1. If you were to divide two numbers, what equals 1? Okay, well that would be anything divided by itself. So 2 divided by 2 is 1. 3 divided by 3 is 1. It's the same thing with square roots. If I have a square root of 2 divided by the square root of 2, that's 1. Square root of 5 divided by square root of 5, that's 1. So what we're going to be doing here when we start talking about rationalizing these denominators, we are going to be multiplying it by whatever that problem's version of 1 is. So notice in this first problem, I have a square root of 5 there, which means I'm going to be multiplying this by square root of 5 over square root of 5, because that's this problem's version of 1. Okay, that's going to make more sense once we start working through these. Okay, so remember, the reason we're doing this is because you cannot have radicals in the denominator. We have to get rid of them. Okay, so I have 4 divided by the square root of 5. So I need to get rid of this square root of 5. So I'm going to multiply this whole thing by the square root of 5 over the square root of 5. That's going to help me get rid of this. Okay, and when we multiply fractions, remember we multiply straight across. So I have 4 times the square root of 5. That's just outside times outside, inside times inside. So that's 4 root 5 over the square root of 5 times the square root of 5, which some of you are probably thinking is the square root of 25, and you would be right, but remember that trick. Okay, any square root times itself is the number underneath. So the square root of 5 times the square root of 5 is just 5. Okay, now I need to make sure there's no simplifying, so let's check 4 divided by 5. Okay, those can't be simplified. Okay, and let's check the square root of 5. There's no perfect squares in that, so we're done with this problem. So I have 4 square root of 5 over 5. Okay, let's check the second one. So the very first thing I need to do here is I need to break this apart. So I need to break it into square root of 3 over the square root of 50. Now, there's actually a couple of different ways you can go from here. Okay, but we do need to get that square root of 50 out of the denominator. If you want to go ahead and simplify the 50, like we did last time, then you can do that. It would simplify into 5 square root of 2. Or if you want to go ahead and just get rid of the 50 now, you can. Just know you're going to be working with bigger numbers. Okay, so I need to get rid of that square root of 50 in the bottom. So I need to multiply it by this problem's version of 1, which is going to be the square root of 50 over the square root of 50. Okay, we're going to multiply straight across. Okay, so on the top I have square root of 3 times square root of 50. That's now going to get me the square root of 150. And then I have the square root of 50 times the square root of 50. Remember, any square root times itself is going to end up with the number underneath. So I'm just going to have 50 on the bottom. And you would think we would be done here, but we have to look at that 150. We have to see if there's any perfect squares within 150, and there are. Okay, I know that 25 times 6 is 150. Okay, well, what is the square root of 25? The square root of 25 is 5. So that's what I'm going to bring out. So I have 5. I'm still left with that 6. So that's going to be square root of 6 over 50. All right, we're almost done. Okay, but I need to check those numbers in front. So 5 divided by 50, if you can simplify that, then you have to simplify that. So what is 5 divided by 50? That's going to simplify to 1 over 10. So what I have now is the square root of 6 over 10. So that's my final answer here. Just always check it at the end, check your final answer, make sure there's no more perfect squares anywhere, and then you're good. Okay, so here we go. This is our last slide. We're just going to look at 4 more practice problems. Okay, so here we go. Number 1, I need to break this apart into the square root of 9 over the square root of 75. Okay, if you want to go ahead and simplify the square root of 9, you can do that. If you want to go ahead and simplify the square root of 75, you can do that. I'm going to work this one both ways for y'all. Okay, so I'm going to go ahead and I'm going to simplify this 9. I'm going to simplify that to 3. And then this 75, I'm going to break into 25 and 3. So I'm going to bring a 5 out. So I'm going to have 5 root 3. Okay, because I want to show you how much this, I actually think this is easier because you're going to be working with smaller numbers here. instead of whatever 75 times 9 would have been. Okay, so now I need to rationalize the denominator, but I don't need to get rid of the 5 in the denominator. I just need to get rid of the square root of 3. So I'm going to multiply this times square root of 3 over the square root of 3. Okay, so on the top, if I multiply straight across, that's 3 square root of 3 over, now this is 5 times 1, which is just 5. But what is the square root of 3 times the square root of 3? Remember, any square root times itself is the number underneath. I know I keep saying that, but I just want you to get that. So square root of 3 times square root of 3 is just 3. So on the bottom, I really have 15. So we have 3 square root of 3 over 15. Okay, and I have to see if there's any simplifying I can do, and there is, because 3 over 15 is going to simplify to 1 over 5. So I have the square root of 3 over 5. I know this looks like a lot of work, but that's just because there's a lot of radicals and it looks like a lot, but it's really not that much work. Okay, but that's our answer here. Okay, I'm going to go back and I'm going to work this the other way. So I need to break this apart into square root of 9 over the square root of 75. Well, let's say I don't simplify anything right now. Or if you want to go ahead and simplify the square root of 9, but not the square root of 75, you can do that. There's multiple options here. Okay, but I'm going to go ahead and multiply times the square root of 75 over the square root of 75. Okay, so on the top, I'm going to have 9 times 75, which is 675. So on the top now I have the square root of 675 over square root of 75 times square root of 75 is 75. It's just now we have to simplify this. Well, I don't know the factors of 675 in my head. This is why I would like to work it the other way so I don't have to deal with big numbers like this. So I'm going to go to my table, okay, and I see here, this is kind of a bigger perfect square, but 225 is a perfect square because 15 times 15 makes it. Okay, so I'm going to break this 675 into 3 times 225. Okay, well the square root of 225 is 15, so that's what I'm going to bring out. So I have 15 square root of 3 left over 75. But I have to simplify this 15 over 175, and that is going to simplify into 1 over 5. So I end up with the same thing, square root of 3 over 5. So either way, pick the way you want to work it. I think it's easier to simplify from the very beginning because you're working with smaller numbers, but it is totally up to you. All right, so that was square root of 3 over 5. Number 2, okay, I need to get rid of that square root in the denominator. So I'm going to multiply this by the square root of p over the square root of p, and I'm going to multiply straight across. Okay, so I have on the top, I'm going to have 2 root p, and then on the bottom, square root of p times square root of p is going to be left with whatever's underneath that radical, which is just p. I cannot simplify that anymore. Those p's cannot cancel because you have one that's under a square root and one that's not. All right, number 3. Okay, notice that 9 is not underneath a square root, so do not take the square root of it. But I do need to rationalize the denominator. So I'm going to multiply this times the square root of 2x over the square root of 2x to get rid of that. So if I multiply straight across, I'm going to have 9 square root of 2x over square root of 2x times square root of 2x is just going to be 2x. Okay, I can't simplify anything underneath the radical. 9 over 2 doesn't simplify, so that is my answer. So notice some of these do not take very long. That first one that we did took a long time. Okay, number 4, I need to multiply this by the square root of 3y over the square root of 3y. And I'm going to multiply straight across. So on the top, I'm going to have the square root of 3y over the square root of 3y times square root of 3y is going to leave me with 3y. So there we go. Okay, so that's it. Make sure when you're doing your homework that if you need any help, you look back at your notes. There should be at least one problem, like everything, on your homework. There should be an example of it on your notes.